Hi everyone, let's continue. So, do you still remember the rational roots theorem? So, suppose we have a polynomial and we have integer coefficients. If an is the leading coefficient. It is the coefficients of the highest terms, okay? And a0 is the constant term. So if an and a0 are non-zero, then each rational root can be written as, so this is going to be a fraction. So p is an integer factor of the constant term a0, and q is the integer factor of the leading coefficient a sub n. Okay, so our root is going to be p over q. That is the rational root theorem. So it means if we have a root that is rational, and then it must be in the list of these possibilities, okay? But it doesn't mean that all the numbers in this list is gonna be our root, okay? And sometimes maybe we have a root is a repeated root, and it won't show in this it won't show by this theorem, okay? So this theorem just provides a list of numbers that are the possible roots. And how to determine whether a number in this list is a root? We plug that number into our equation, okay, our polynomial equation. If we get 0, then that number is the root. If we don't get 0, then that number is not a root. Okay, let's look at the following example. So we want to find all of the roots of this degree 3 polynomial, and we want to determine its multiplicity. So here, I give you the answer, but please don't look at it. So suppose we don't know the answer. Then how do we find it out? Well, if it's quadratic, we can factor it or use quadratic formula. But for degree is higher or equal to 3, we have to use this rational roots theorem. Okay, if we know there are some rational roots. Okay, so first steps, we look at factors of the constant term. The constant term is 4. So the integer factors of 4, they're plus or minus 1, plus or minus 2, and plus or minus 4. And the integer factor of the leading coefficient is 1. Well, that's plus or minus 1. And then what are the possible roots? We use these numbers divided by that number, okay? So plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 2 over plus or minus 1 is plus or minus 2. Plus or minus 4 over plus or minus 1 is plus or minus 4. Okay? So, if the leading coefficient is 3, then the integer factor of 3 is going to be plus or minus 1 plus or minus 3, right? And then your possible roots could be plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. Okay, but in this case, we only have 1, so that's why it looks like this guy is just this guy. But in fact, that is, we use this guy and then divide it by that guy, okay? Alright. So we get a list of numbers. Let me ask you questions. How many roots shall we expect? So this guy is degree 3, so we should have 3 roots, right? 3 roots. So usually a degree n polynomial should have n roots counting multiplicity, including complex roots. Okay. So let's continue. Okay, let's try the numbers on the list. So try x equals 1. Then f of 1 is 1 plus 2 minus 7 plus 4. Oh, what happened? That equals 0. Yes. So this is degree 3 polynomial, right? So we just need to find one root from the rational root theorem. Then we can use long division and get the remaining quadratic factor. Okay, for quadratic factor, we can always factor it using just by looking at it, or we can use the quadratic formula. Okay, so here, let me write down here. Oops, I need to use. What happened? Okay, so I want to say, if we're giving degree 3, need to use rational roots theorem to find one root, and then long division. Okay, if we have degree 4, let me write it better. So if we have degree 4 polynomial, we need to use rational roots theorem to find 2 roots. Okay, then we can use long division to find the remaining quadratic factor. So far so good. And here we're so lucky, we just plug in the first number and we find the roots. Okay, in general, you might need to go to try more numbers on the list, okay, until you find the roots. So because this guy is a root, it means x minus 1 is a factor of f of x. Now let's use the long division. So we have x cubed plus 2x squared minus 7x plus 4, and divided by x minus 1. Okay, do you still remember long division? What? Multiply by x to get x cubed? Well, x squared. So x cubed minus x squared times minus 1 is minus x squared. And then we use the first line, subtract the second line. X cubed cancel. 2x squared minus negative x squared is the same as 3x squared. And then minus 7x plus 4. And then here we have plus 3x. 3x times x is 3x squared. 3x times minus 1 is minus 3x. Use the first line, subtract the second line. Minus 7x minus negative become plus 3x. So minus 4x plus 4. And we get minus 4, right? So minus 4x and then minus minus become plus. Awesome. The remainder should be 0. Because we just said x minus 1 is a factor. So the remainder should be 0. So f of x is then x minus 1 times, what's the quotient? X squared plus 3x minus 4. And can we factor it further? Well, x, we can do plus 4, and then we can do minus 1 again, right? And, oh, you see, we have 2 factor of minus 1 and 1 factor of x plus 4. So what are the roots? We have 1 is a root with multiplicity 2. Multiplicity is the number of copies of that corresponding factor. And minus 4 is a root with multiplicity is 1. So far, so good, everybody? Okay, good. Now let's continue. Yes. Right. So I give you the answer right here. Yeah. Yeah. So this is how we get this answer. Okay. And the multiplicity is the number of copies of the corresponding factor appear in the factorization. Okay. Let's continue. Modification of Newton's method. So for double root x to x asterisk. So this is the true value, okay? And f of x equals x minus the root square, okay, h of x. And here, because the multiplicity, double root means the multiplicity equals 2. So that's why this guy equals 2. And we also know that h of this root is not 0. Okay, then we can modify the Newton's method. Do you still remember the old Newton's method? Old Newton's method, we have xk minus, we don't have this 2, yk over yk prime. Okay, but the modification of Newton method, we insert this 2. Okay, here. And in general, for mth order root, we insert the m here. So far, so good, everybody? Okay, now let's compare how well this modification is using the example we just did. Okay. So, here we know 1 is a double root, right? Okay, let's find x3 using x0 equals 0.5. Part A, use Newton's method. Part B, use the modification of Newton's method. Okay, so first we need to find the derivative, right? So the derivative equals 3x squared 4x minus 7. So far so good. We're taking the derivative of this formula. We don't want to use this formula because we don't want to do product rule, right? We just want to do power rule, so we use the left formula. Okay, and then we get the iterative formula. That's xk minus yk. What is yk? It means whenever we see x in the formula of f, we replace it by xk. So xk, maybe let me write it down one more time so you know what is the Newton's formula. So that's yk over yk prime. So yk is xk cubed plus 2xk squared minus 7xk plus 4. All over y prime, so 3xk squared plus 4xk minus 7. So far so good, everybody? So this is the iterative formula. Now let's start. x0 is 0.5 and then x1 equals, do you still remember how do we use our calculator? Okay, so how to use our calculator. So we first enter, we put 0.5 and then we enter. Okay, then we do answer minus parentheses answer cube plus 2 answer square minus 7 answer plus 4 close parentheses divided by another parentheses 3 answer square plus 4 answer minus 7 close parentheses and enter. So far so good, everybody? Okay, now let's plug in our calculator. Alright, so far so good, everybody? And we first do 0.5. Enter. Okay. And then we do, let me move this up a little bit. Okay. We do answer minus parentheses answer cube plus 2 answer square. Okay, so let's see here. I have to press this button and this guy square and then minus 7 answer plus 4 divided by okay, let's see. I cannot use the parentheses in my keyboard, it turns out. I have to use the parentheses that in this bottom, okay? And then we can do divided by 3 answer square and plus 4 answer minus 7. Okay, then we have everything. Now let's double check it. Yeah, looks like we have it. Okay, enter. So this is x1. So far, so good, everybody? Okay, so this is x1. Let's write it down. So 0.76470588824. And let's write down here. Let me use orange color. Point 76470588824, right? And then how about x2? Well, we don't need to type the whole thing again. Remember, we just go up to that line, right? Go up to that line, and then enter. Okay. So yeah, please make sure how to use your calculator. So not this one. Okay, so what I do here, this online calculator, I don't have to go up button, but I can do copy and paste. Okay, you see, this is 0.885331347. Okay, so let me change back to my orange color. 0.8853331348. Okay. x3. So we just keep you can double click the enter, see whether you will get it. Okay, so what I do is I paste again. So 0.94 3346541 9433465411, right? Okay. So if you need type to like plot numbers in your calculator, don't forget you can always pause the video at any time, and then or you can change the speed. Okay, so we do keep going. 0.9718. Okay, 6526. So here, even though the problem only asks us to find x3, I really want to do more with you. Okay, do you remember when we stop? Usually if it converges, you will see when you type it again, the number is gonna be the same thing. It will stabilize. See, now this is x5 0.985955826. And how about, let's continue. 99298900302. Okay, so 0.99298900302, right? And 0.9964 96978. So far so good, everybody. Let's just do one more. 9982491032. Okay. Okay, so you can see it's converging, but it's converging very slowly, right? Okay, now let's do the modified Newton's method. Oops, where is it? Okay. Let me change a different color here. How about green? Okay. So modified Newton's method. All right, and because we know 1 is the double root, so the multiplicity equals 2, right? Then what is our new formula? Well, our new formula is xk minus 2 times yk over yk prime. So we use the previous formula, but we have a 2 in front of it, right? Okay. Okay, so far so good, everybody? All right. So x0 is 0.5. And now what's x1? Okay, so let's get back to our calculator. Let's plug in 0.5 again. Enter. You have to do that because you want to next line if you mean you want to press the answer, then you need a 0.5 in the previous line, and then we know that is the answer. Okay, so and then we can copy and what we had before and paste it, but here we have an extra 2 in front. So far so good, and we click enter. So the answer is 1.029411765. 1.029411765. And how about x2? Well, you go up to the previous line and just enter it. Right, 1.000085749. 1.00085,749, right? Okay, and do one more time. Ooh, 1 point, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. Oh, okay, so x3 equals 1.80. Oops. Okay, sorry, I pressed the wrong button. Oops, sorry. We have 8 zeros and then 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. See, it converts so quickly. Oh, okay. And it's gonna stabilize. So far, so good, everybody. And we know the answer is 1. Okay, and see, it converts so quickly. Compare with the old Newton's method, it converts very slowly. Okay, so you can see the modified Newton's method actually you can get faster convergence. And usually the Newton's method converge quite fast. Okay, but sometimes when the derivative is 0 near the true 0, then the convergence is not fast. Okay, but we can modify the method to preserve the rapid convergence of the order. Okay. All right. Let's see, and make sure in this case, we have to know the order of it. So if the order is, the multiplicity is m, then we multiply by m here. Okay, so far so good, everybody? Okay, let's continue. Okay, how to use MATLAB. Okay, so consider the following function, f of x, which has a double root near x equals 2. Okay? And what is the derivative of that? Well, here we can use product rule, right? Derivative of the first guy times second guy plus the first guy times the derivative of the second guy. Well, the derivative of the first guy, this is a chain rule, right? So 2 times x squared minus 5 and times the derivative of x squared minus 5, which is 2x. That's why we have 4x here. Okay, and times the second guy plus first guy times the derivative of x squared minus 3 is 2x. So far, so good, everybody? Okay, now let's use Newton's method. So here, let's see where. Okay, so open your MATLAB or Octave. Okay, make sure the file browser is in the M function folder. Okay, and next we enter the syntax brackets x prime y x comma y equals Newton. Inline function x squared. Oh, here there is another parentheses in front of it. Okay. Minus 5 square and times. Okay, so here don't forget, if we mean times, we have to do this asterisk. Okay. By the way, in the M function folder that you download, there is a Word file which I include all the easy to make mistake that I made before. So let me see. Let me show you here. So once you download it in your computer, you see this MATLAB function code. So open it. Okay. So here I summarize all the MATLAB syntax for different session. See, this chapter we have bisection method, regular Fossey method, secant method, and Newton's method, and then modify Newton's method. Okay, so I provide the syntax and I also provide an example. Okay, and yeah, so sometimes you have to be very careful. Okay, don't just copy and paste, because sometimes the format of Word will cause a problem. Okay, you really need to type it. See, I include all of the sessions we will cover in this course, and I also give you some easy to make mistakes. Okay, so if we want to write multiplication, we need to write this asterisk. Okay, so instead of writing 2x, we should write 2 asterisk x. It's very easy to forget some parentheses or this guy, apostrophe. Okay. And it's very easy to mix the comma and the semicolon. Sometimes if you just want to copy and paste the codes from Word to MATLAB, this apostrophe will cause a problem. And this guy means the transpose in MATLAB. And we need to write log x in MATLAB if you mean ln of x. Oh, this is quite interesting because you see log in your calculator. Log means base is 10, but actually in MATLAB, log means base is e, and you don't write ln. They don't have a ln in the MATLAB. Okay, and they don't have an e in the MATLAB. They think e is a variable. So if you mean the exponential function, you should do exp up to the 1. Okay, when working with vectors, be careful with the dimensions. Here the asterisk means matrix vector multiplication. If we want to have point-wise multiplication, we have to put a dot in front of it. Or if we want to have a point-wise power, like each entry of a vector raised to the power of 2, then you should do dot hat 2. Okay, so and then see the following link. Right now, in this chapter, we're doing scalar value function, so that's fine. But later on, in the later chapter, we're dealing with vector value function. Okay, yeah. So if you have any questions, Google them and you will find the answer easily, or you can email me. Okay, so here I collect all the detail of the code and some example. Okay, so that's why it has a lot of pages. So yeah, I provide a lot of examples, screenshots. Hopefully, if you have questions, look at this Word document. So far, so good. Okay, and let's continue. Okay, so let's type it here. And so we first type the function, and then next we type the function, the derivative of it, right? In line 4 times x squared minus 5 times x squared minus 3 plus 2 times x times x squared minus 5 square. Okay, that finish it. So it's from the initial point is 2, right? It's not interval, unlike bisection method, regular Fossey method, and secant method, we were given an interval. Here we just have an initial point, one single value. Okay, the tolerance, let's do 0.0001, let's do 10 steps. Okay, so this is what we get. So far so good, everybody? Okay, you can see the number is getting closer, smaller, right? And here it's converging, and you can see here. So we'll get x is 2.2361. Okay, the MATLAB align better. Okay, so this is what happened when you use MATLAB, but I don't have MATLAB in my home computer. Okay, so how about the modified Newton's method? Oh, let's see. The modified Newton's method, we have a different syntax. So, but keep in mind, here we have the Newton's method converge, but it takes 10 steps to converge. Now let's look at the modified Newton's method. So we can just go up, and here we just change this guy to Newton modify. Modify. Okay, and we have the function, we have the derivative, we have the tolerance, we have the k-mass, and we have the n. N is the multiplicity. Okay, so here we know it's a double root, so multiplicity is 2. So far so good, everybody? Okay, and we enter it. See, it converges in 6 steps. So faster. See, it's faster than the Newton's method. I should say modify Newton's method. Okay. So far so good, everybody? All right. So that is the modified Newton's method. If we know the multiplicity of the roots, we can use modified Newton's method, and then it can still converge rapidly. Okay, and this problem, you see, near 2 is actually the root is square root of 5. So square root of 5 is close to like 2.2361. All right. Okay, let's continue in the next video. We will talk about something new. All right, see you soon. Bye.